All right, part B. We're looking at graphs of these functions, power functions. Okay, so what's the power on this function? 4, constant variation. 2, okay, that's straightforward. And so then which one looks the most like this? A, B, or C? C, and it goes from negative infinity to infinity. Yes, Mr. Swenson. Okay. All right. I just dumped it yesterday. There is a bunch, I'm sure, in the recycling big can way over there. Yeah. All right. So the domain for this is what? For the red one I circled. Domain is negative infinity to infinity. What's the range? 0 to infinity. So it would be this one. Would this be an odd or an even function? Well, if you look at this, this is an even number, so it'd be an even function. But to be an even function, it has to flip across the y-axis. If it flips across the y-axis only, it's an even function. If it flips across both the x and the y-axis, then it's an odd function. And if it doesn't do either of those, it's neither. So that is an even function. This one, what's the power on this function? What's the power on a square root? 1/2. The power of a square root function is 1/2. So the power is 1/2. The constant variation is 2. And earlier before lunch, I showed you how to do a square root, what it looks like. And that looks like A, B, or C. C. It goes up like that. Okay, square root functions go like that. That's one of our 12 basic functions. So what's the domain and the range? 0 to infinity and 0 to infinity, because it's above the x-axis. It starts at 0, 0, and it goes up from there. Odd, even, or neither? Does it flip across the x-axis or y-axis? No, so it's neither. Okay. From a normal x to the fourth function, if we put a 4/17 in front, does that number in front affect it horizontally or vertically? The number in front affects it vertically. It has to be in parentheses. If it affects it horizontally, it would be like 1/4 x to the fourth. Okay? It would have to be inside to affect it horizontally. Okay? So, since if it's less than 0, it's a shrink. If it's bigger than, or if it's in between 0 and 1, it's a shrink. If it's greater than 1 or less than -1, it's a stretch. So it's a shrink vertically by 4/17. Is this an even or odd function? Even, because it's an even power. So if it's an even function, it should look like A, B, C, or D. Should look like B. Okay. -3/8 to the fifth. What does the -3/8 do to it? Okay. The normal x to the fifth goes like this. The -3/8 makes it opposite. Makes it go like this. Okay. And then 3.8, since it's smaller than -1, it's a stretch. It's a stretch, and it's reflected. It's a stretch vertically, and it's reflected over the x-axis. This flips up to here. This flips down to here. So what does it look like? Well, it looks like choice D. Because this one, it moved up 1, and it's not supposed to do that. Even or odd function? Odd function because it has an odd power. Okay, so that one's similar to one we've had before. Now, matching the curve. Green curve, red curve, blue curve. What curve looks like negative 3/5 to the fourth for the right side of the graph? Negative 3/5 to the fourth. Well, if it's a fourth powers do this, right? They look like a parabola. But since it's negative, it would do this, right? So it would be which color? Blue. On this one, the 1/4 power is a fourth root. So square roots, fourth roots, anything like that go off like that. Okay, since it's a positive 2 in front, makes it go twice as high. But then it would be which one? Red. Okay. Negative 2x to the negative fifth is the same as negative 2 over x to the fifth. And that's like the 1 over x function, which looks like that and that. But since there's a negative 2 on top, they flip over the axes. So it'd be this and this. So it would be blue. It would be blue. Okay. This one, our k is our coefficient, which is, in this case, 3. And our a is our exponent, which is? So if it's x to the negative fifth, it would be like 3 over x to the fifth, which is like our 1 over x function, which looks like this and this. So which function do you think it would look like? It would have to be probably, it's stretched vertically, but I think it would be most like B. I think it would be most like B because 1, 3 would be a point. That's also 1, 3. And then if it was 2, it'd be 3 over 2 to the fifth or 3 over 32. So it'd be down here. So B looks like it would be the one that makes sense. Odd or even function? It is an odd function. It is an odd because you can flip it over the axis. So it would be choice A from negative 5 to 5. So you have a couple like that. All right, the volume of gas held at a constant temperature in a closed container varies inversely with the pressure. V equals K over P. Okay? If the volume of gas is 1,200 cubic centimeters when the pressure is 450, find the volume of gas at 400 millimeters of mercury. Okay? So 1,200 equals K over 450. So you take K equals 1,200 times 450. What's 1,200 times 450? Somebody with a calculator, please. $540,000. That's what K equals. So then we set it up again. What is the volume when K is 540,000 and the pressure is 400? Well, the 0 and the 0 cancel. So 5,400 divided by 4 is what? So it'd be 1,350 cubic centimeters. Okay. And x to the 1/3 power goes like this and like this. Does it have any symmetry? Is it symmetrical with the y-axis? No, because it's not the mirror image over the y. What about the x? No. What about the origin? Yes, it is symmetric with the origin. Okay, it is symmetric with the origin. because you flip, and that's what you do around the origin. Okay, so there's 13 problems. I'll have you work on that. And then tomorrow we'll do another section.